Welcome to my presentation regarding the current status of my research. Um, the title is Complex Training Considerations and Applications for Long Distance Running Performance. Research problem. Running performance strategies focus mainly on fundamental physiological factors uh, such as the interaction of maximal oxygen uptake, lactate threshold, and running economy. These factors are considered crucial in influencing running performance. However, research suggests the importance of neuromuscular attributes such as motor unit recruitment, muscle stiffness, and force development in contributing to running performance. The purpose of this presentation is therefore to examine a multimodal resistance training strategy called complex training, which utilizes the pairing of both heavy resistance training and plyometric training in the same session. Both of these separately, heavy resistance training and plyometric training, have been suggested to have neuromuscular effects in increasing running performance. So, in a systematic review by Denadai and others, examined explosive training and heavy weight training and the effects on improving running economy in endurance trained athletes. Um, the research purpose was therefore to systematically examine different research that was published in peer review articles on the effect of concurrent training modalities such as traditional, plyometric, or mixed modalities and their effects on running economy. Looking at assumptions and limitations and strengths, one of the assumptions going into this is running economy is a predictor of endurance running performance. Submaximal endurance training can improve running economy. Another assumption based off of other supporting evidence is explosive or heavyweight training added to endurance training enhances running economy. Some of the limitations were that the prescription parameters were very broad, meaning that the prescription of what type of exercises were used in the different studies. And this opened up some of the variability that may have a influence in decreasing the internal validity of the independent variables, such as some of the confounding effects between age and training level. Um, the strengths were the inclusion criteria used using only randomized control studies, and then also only including studies that used pre and post testing in measuring running economy. The methods used to collect and extract data started with a broad computerized literature search of 119 relevant studies. Out of the 119, 79 studies were excluded based on the review and abstract. Also using inclusion and exclusion criteria. Out of the total number of studies, 16 were chosen for meta-analysis. These 16 studies were independently evaluated, and then also independent variables were examined for training efficiency, such as subject characteristics and strength training elements that may influence the meta-analysis. The results of the review or meta-analysis showed a small but significant effect on running economy, and moreover, heavy weight and explosive training variables used increase these effects in many of the studies. Different strength training modalities have been added to try to enhance or to attempt to improve running economy and aerobic performance of endurance runners. The present meta-analysis shows that concurrent training has a significant beneficial effect on running economy in endurance trained runners. This is based on the inclusion of research that has examined the effects of using heavy and explosive training interventions. Furthermore, the research using strength training modalities were very similar to the strategies used in complex training, such as heavy resistance and plyometric training. Although this systematic review and meta-analysis did not specifically address complex training, there were very similar correlations in relation to other potential mechanisms that it could explain the improvements in running economy, such as the stretch shortening cycle function or movement mechanics of running. Basically, a lot of these strength training modalities can improve both peak performance parameters and the shape of the power, force, velocity, and displacement time curves. So, therefore, studies investigating the effects of heavy resistance and explosive training on running economy could produce implications for specific training strategies in this field relating to long distance running. All right, the next article is going to be an original research study that was done in 2020 this year. I used this article because there was no direct review or systematic review on my that addresses my topic specifically. So I used a high-level article that was very specific to my research. It's called Concurrent, Complex, and Endurance Training for Recreational Marathon Runners, and then the effects on neuromuscular performance. So as I mentioned earlier in this presentation, that a lot of the research relating to running performance has mainly focused on the physiological factors such as VO2 max, lactate threshold, and running economy. Most of the time, the research uses the neuromuscular adaptations as secondary factors in helping to support some of the effects that are taking place. For this particular study, it really goes a lot deeper in looking at the neuromuscular factors that take place in regards to how we are increasing running performance. So this research purpose, the primary purpose of the study was to investigate the effects of a 6-week concurrent, complex, and endurance training program on neuromuscular adaptation, running economy, and VO2 max in recreational marathon runners. There was also a secondary aim was to compare the effects of different concurrent training modes by itself, meaning heavy strength training along with endurance training, or endurance strength training along with endurance training, and how this improves neuromuscular efficiency, thus resulting in increased running performance. So the assumptions of this particular study, it was assumed that neuromuscular characteristics are vital based on other research. For example, at the initial contact, and I'm giving you an example of the mechanical perspective of the running gait is on initial contact of the foot with the ground, lower limb muscles contract eccentrically to absorb the impact force and isometrically during the middle stance phase to increase the oscillation of the center of mass. That was done through Lee and others, which they also have done this study. The muscles contract concentrically, similar to motor, and plyometrically, similar to a spring, to generate substantial force to propel the body forward. That was also supported by Lay and others in another study. So another assumption would be neuromuscular characteristics such as muscle force and power eccentric capacity could effectively translate to cardiorespiratory capacity or increased cardiorespiratory capacity into efficient running mechanics and performance. So this is something Barnes and Kidling did through an original research in 2015. The neuromuscular characteristics are a very important part of this research. So in regards to another portion of what is assumed is in well-trained endurance runners, strength training elicits increases in neuromuscular adaptations, which coincide with improved performance. Another and the last assumption is complex training can elicit a post-activation potentiation response, thus enhancing power output and theoretically improving long distance through training adaptations in submaximal force production. Going into the limitations that were observed is that the researchers thought that what was limiting could be the 6 weeks. They think that research should also explore going beyond 8 weeks and how this may be more effective for recreational marathon runners or long distance runners. Moving into the strengths of the research, there are many strengths to the study, and they're the first to look at the effects of complex training using a concurrent training model with endurance training, along with examining the effects of post-activation potentiation on long-distance running. This looks at the neuromuscular factors and the physiological enhancements as a result. Some of the other strengths of the study was the homogeneity of the participants, meaning that they made sure that the groups that were put in the different areas of heavy strength and endurance strength were very similar, meaning that they were similar in terms of their training status and relative strength and their running experience, which also leads into another strength is in order for them to do this, they had to be very methodical with their pre-testing to arrange the groups closest to their training status and relative strength. So the present study used between group repeated measures using two-way repeated ANOVA. Furthermore, because of the multiple variables, Bonferroni post hoc test was used in setting the p-values for each variable being measured for significance. So the methods used to collect data was first that the sample was broken down originally from 72 initial volunteer runners, and eventually, because of the exclusion and inclusion criteria, was broken down to 38 recreational marathon runners participating in this research test. Each one of these runners went through 1 week of pre-testing, which covered body composition, 1 RM back squat, squat jump, and counter movement. This is to ensure a homogeny of the each person in each participant in the study. This also allowed for making sure that each group was also the same in regards to any of the other confounding variables involved. The groups were separated into 3 groups. The first group was a complex training group. The second group was heavy strength training group, and the third group was endurance strength training group. All these groups took part in also having to perform a endurance training program, also related to concurrent training modalities. The training lasted for 6 weeks. Each one of the groups was required to do 2 days per week of their concurrent training, obviously using each designated training protocol for each group. This is, again, complex training, heavy strength training, and endurance strength training. And then this also coincided with 4 to 5 days of endurance training. The independent variables, obviously being the training protocols, were examined after the 6 weeks was completed, and then post-testing was done, again repeating body composition measurements, 1 RM back squat, squat jump, counter movement, to see if there were any, obviously, changes from the training intervention. The results of this current study, or the present study, the analysis showed a significant effect in the complex training group and the heavy strength group on running economy. The endurance training group did not show any significant changes after the intervention. And this just supports going back to some of the earlier reviews about heavy strength training and explosive training, showing that they have significant effects on running economy. So implications for practice. So from a practical application perspective, this study suggests that the use of complex training along with a well-developed periodization plan can increase strength relating to mechanical patterns involved with the running gait, and then also can improve overall strength. In terms of practical application for coaches, could use this type of training to help, obviously, increase their abilities through focusing on the neuromuscular attributes or characteristics rather than the aerobic capacities of the runner. Because the heavy strength training group had very similar results in regards to their increases in performance, coaches could effectively also use this type of training, which referring to heavy strength, as an alternative to runners that are not adequately strong. So similarly to the well-developed periodization, it could be used as a preparatory block for maybe about 2 weeks before actually including a complex training protocol. This will help refine the strength for the plyometric techniques required to to perform those movements efficiently, and then will also reduce the potential risks of injury during the training. So basically, in summary, For recreational marathon runners or long distance runners, it's suggested that 6 weeks of complex or heavy strength training 2 times per week could be added to their endurance training, so concurrent, to optimize their endurance performance. So, conclusion and future directions. Based on the current area of research, there are still some issues needed to be addressed. Such much of my research started with examining the effects of post-activation potentiation on running performance. As my research has evolved, I have found that this type of research is still being developed. Hence why in this presentation, the systematic review and meta-analysis may not appear to directly relate to post-activation potentiation on running performance, but it brings up some foundational research around heavy resistance, known, and plyometrics, which have been both known to elicit a post-activation potentiation response. So again, as the research evolved, I found that this type of research is still obviously being developed. And only a handful of studies directly related to PAP or post-activation potentiation on running performance. Now, however, PAP has been thoroughly examined from a classical perspective using more clinical approaches such as muscle testing and muscle morphology and how this translates to explosive related movements such as sprinting, jumping, throwing. This classical approach has made it challenging for researchers to integrate post-activation potentiation effects on running performance, since it has been mainly studied as an acute or short-lived response, whereas long distance running is based around chronic adaptations, both on the physiological and neuromuscular levels. So just to bring this up quickly, is that, and this is beyond the scope of obviously this presentation, but in a recent article by Belosa and others, tries to bring a new perspective that may make both measuring and categorizing how post-activation potentiation can affect long-distance running performance and the other types of sports activities. They may not be dependent on explosiveness, but on endurance. The new category lends the use of the classical PAP perspective, which, just to give you a quick overview, PAP is a muscular phenomenon that consists of an acute increment in strength and power performances as a result of recent voluntary contractile history, which going into complex training, which elicits PAP. Complex training involves the heavy resistance and also the plyometric. So in this article, it uses how post-activation can affect maybe sport activities that may not be dependent on explosiveness, but on endurance. But because classical PAP has always looked at it that way, it's hard for research to show another perspective using that same classical perspective of post-activation potentiation. So the new category for PAP that lends the use, still using the classical PAP perspective, but refines it to be more adaptive for further research or future research and applications. The category is called post-activation potentiation performance enhancement. So that kind of gives an idea of both what we're looking at for the future in regards to my type of research and what research is already being developed. Again, going back to, besides, obviously, running performance is highly dependent on the aerobic capacity, but oftentimes neuromuscular characteristics are kind of put on the back burner, let's say, but they are considered equally important for long distance running performance. Again, when the primary goal is to simultaneously develop maximum and eccentric strength within a training period, complex training can be considered an efficacious and practical method, again, to increasing long distance running performance. So I hope you enjoyed my presentation, and if you have any questions, please feel free to jot them into the discussion.